Hello, how are you, my dear friends? Today we will discuss some basic tools about the thermodynamics or the some basic general knowledge about the thermodynamics. In the thermodynamics, we have to introduce ourselves. So, introduction part number 1, number 2, terminology, and in the terminology we have 4 thermodynamic variable. These are 4: entropy, pressure, volume, temperature. Okay. Next, thermodynamic potential. Thermodynamic potential means we have enthalpy, gives free energy, Helmholtz energy, internal energy, and we have for another things the path function. And the thermodynamics, we have the thermodynamics function. We have thermodynamic function. We have 4 thermodynamics function. We have thermodynamic we have 4 thermodynamics function. Thermodynamics function means W, Q, and C. In the whole thermodynamics chapter, we see only these alphabets, and these alphabets have some specific meanings. Let us discuss. We have thermodynamics variable. Thermodynamics variable means S. It is an entropy. P stands for pressure. V stands for volume. T stands for temperature. We have only control in the laboratory of these 3 variables, and we have another thermodynamics potential. We have H. It is called enthalpy. It is a derivative of heat. G. It is a gives free energy. Helmholtz energy, internal energy. Now we have third thing. We have the process. Process is of the 2 type. One is the reversible process in the chemistry, and irreversible process. And according to the variable change, we have another type of process also. We have for isobaric, isochoric, isothermal and adiabatic. We have the four thermodynamic process, and fourth, we have four thermodynamics law. Four thermodynamics law. First one is the zeroth law. Second is first law of thermodynamics. Second is second law of thermodynamics. And the fourth one is T cube law. Okay. So, in the whole chapter, what we have in thermodynamics, we have number one, four thermodynamics variable, second one is four thermodynamics potential, third one is we have four thermodynamics processes, and we have gaseous equation. First one is ideal gas, second one is real gas. Ideal gas equation is equals to PV is equals to nRT, and the real gas have represented by van der Waals equation. Okay. So, in the whole thermodynamics, what we do? In the whole thermodynamics, we calculate work done by the gas or work done on the gas. In the whole thermodynamics, we calculate only work. So, if we discuss work, means if we supply some amount of heat, like plus Q, system do some work like minus W in IUPAC. This is according to IUPAC convention. This is according to IUPAC convention. But there is some problem. If we supply some heat to our system, but system cannot convert the 100% heat, cannot convert. So, the remaining part of the heat is called internal energy. Remaining part of the heat called internal energy means we supply some amount of heat to our system, means we have change in internal energy and we have work done. This is the IUPAC convention. So Q is equals to delta U internal energy plus W. Okay. This is the first law of thermodynamics. Thermodynamics, first law of the thermodynamics. So, we calculate for the ideal gas, we calculate work done, reversible process, and we have irreversible process. For the reversible process, we have another 4 type of process: isobaric, isochoric, isothermal, adiabatic. And we also calculate work done. We also calculate work done for ideal gas, for irreversible process, for isobaric, isochoric, isothermal, and adiabatic process. Okay. And we have real gas, means real gas equation, van der Waals equation, P is equals to V minus A upon V square, V minus B is equals to nRT. Okay. Ideal gas have equation PV is equals to nRT. Okay. For the real gas, we have reversible and irreversible process, and we calculate for the same isobaric process, work done for isochoric process, we calculate work done for isothermal process. For real gas, we calculate work done for adiabatic process. For real gas, we calculate irreversible process, work done for irreversible process for the real gas for what? Isobaric process, isochoric process, isothermal process, and adiabatic process. So, we have, and in this process we have expansion of gas and compression of gas. In the whole thermodynamics is a very vast topic. So, if we start to calculate the 4 and 4, 8, 8 and 8 is equal to 16 type of work, and 16 multiply expansion and compression. So, total 32 formulas of for the work done. Okay, that's why the thermodynamics is very vast. So, we have to make some roadmap of thermodynamics in our brain. Means we have to remember the key point. Just explain this. In the whole thermodynamics, we have the 4 thermodynamics variable and the 4 thermodynamics potential, 4 thermodynamics variable and the 4 thermodynamics potential, and 4 thermodynamics process: isobaric, isochoric, and isothermal. Isobaric, isochoric, isothermal, adiabatic. Okay. And we have the gaseous equation for ideal gas and for the real gas. Ideal gas, we have PV is equal to nRT, but the real gas, the vast studies, the equation is the van der Waals equation. We have also more equation for the real gas, explanation of the real gas, and for thermodynamic process, 4 thermodynamic variable, and in the thermodynamics, 4 thermodynamics law. Okay, so in the thermodynamics, we have 4 thermodynamic variable. The key point, 4 thermodynamic potential. Third one is 4 thermodynamics process, and we have 4 thermodynamics laws. Okay, and now we have 2 types of gaseous equation. Gaseous equation, one is ideal gas and second one is van der Waals gas, the real gas. Okay, real gas. So if we say the ideal gas, it means in the science, if we say ideal, means it is hypothetical. Ideal gas means it is hypothetical. So gas is real. Real gas representation given by the van der Waals P minus A upon V square, V minus B is equals to nRT. Okay. So today's topic of discussion, we stops here, and We will meet in the next video.